Hello everyone, this is Ashfaq Ahmed and I work in the field of bioinformatics and structural biology. Today I'm going to talk about the docking with AutoDock Vina, or I will train you or I will teach you how you can do molecular docking with AutoDock Vina. I will try my best to cover this tutorial with the most easiest way that you can follow. So let's start. What programs we will need? We will need two programs, that is called MGL tools, and the second one is called AutoDock Vina. MGL tool, the size of MGL tool is 80 MB and the size of AutoDock Vina is 500 KB. So both are relatively smaller. From where to download it, I will drop links, the download links of these programs in the description section of this video. If you don't have this program, just copy those links and download those programs for yourself. Besides programs, what extra things you will need? You will need a receptor molecule or a protein in PDB format. I hope it will not be an issue for you. You can take it from the PDB or you may have your own model you have achieved from somewhere. A ligand molecule, a compound you want to dock with your protein, but it should be in PDB format. The problem comes for the people who are new in this field that they have a ligand molecule in mol or SDF or mol2. So if they are watching this video, they will think that how can we achieve the PDB format? It is very easy and very simple, but here I'm going to tell you how can you do that very easily. If you have any program, any visualizer installed, for example PyMol, or for example Discovery Visualizer or DSViewer or Chimera or VMD or any other, just open your ligand molecule in any of the visualizer, then click File, then click Save As and save as PDB format. That's it. Okay. Also, if you don't have these visualizers, then what will you do? You can install this program OpenBabel, or if you don't want to install, there is an online server for this program. Just input the coordinates of your ligand and paste it there and save it in the PDB format. Let's start our docking. This is the download link or the download website for the MGL tool. Once you open this link, which is present in the description section of this video, you can scroll down and you can download a specific program which is compatible for your system. If you are using Windows, download this one. If you are using Linux, download one of them. If you are using Mac, download this one. Okay, this is the download link for AutoDock Vina, and I drop this link in the description section of this video. You can find it there. If you are using Windows, so here is your target, or this should be your target. Once you download it, you will have a download folder. You will see this file here. Right click and run as administrator. For AutoDock Vina, right click and install. Once the programs are installed, then you need to check it. How you can check? Click your C, click your program files, check these two directory. One should be with the name the Scripps Research Institute. Click here, Vina. Okay, you should see 3 files here, and go back a little up. You will see MGL tools. Click here, you will see all such stuff. That's it. The next thing, your programs are ready. Now we will do some docking stuff. You will need to create a folder anywhere in your computer. For this video, I have created a folder on my desktop. You can see here, and its name is 123. It's easy to find for me, therefore I name it always 123. So this folder contains 2 files. One is my protein or a receptor. The second one is a ligand or a compound. I want to dock this ligand compound with this receptor using AutoDock Vina. What will you do? The first step you need to do, you need to come the C directory, click the program file, Scripps Research Institute, Vina, and copy this option, the first one, the Vina. Copy, do not cut, copy and paste it the 123 folder. Why you need to copy it here? Because I know most of my listeners are not expert in computer science. So I'm trying my level best to make things easy for them. So this Vina program should be copied to the folder your files are. Okay, now let's start. How to start? You need to open the MGL tools we have installed, so you will see this kind of thing on your desktop after the installation of Vina. So you just click AutoDock, and it may take 10 seconds or somehow. Okay, that's it. You can see this window. Just make it bigger. Okay, the first step is we will prepare our protein molecule for docking. It's very easy. You need to click here and read molecule, file, read molecule, then click desktop. My files are in the 123 folder here, and whatever the name is, in my case it is protein. Click protein. Now you can see your protein in this window. The next step is you need to click edit, and now come to hydrogens, click add, select polar only, and OK. You can see the white spots, these are hydrogen. If you are using a model structure, this step is not necessary, but if you perform it, it doesn't matter. So I suggest you to perform. Okay. Now next is you need to click this grid, then come to macromolecule and select choose. Do not select open because the molecule is already open. You can see here in your browser or in your GUI screen. So click choose. Once you click choose, you will have this kind of smaller window, and it will show only one name, that is your protein. Click this protein and select here. You will have this kind of messages. Click OK. Once you click OK, you will have this kind of screen, and just go to your desktop, and select that 123 folder and name, let's say I will name P1. P1 means my protein name, whatever you want to do it, but okay. And then write PDBQT and save. You can see here the 123 folder contains an extra file P1 we have created just now, and ensure that it's mentioned PDBQT file here. Okay, now come back. Now we want to select a grid box. How will you select a grid box? Just click grid. Now after that you can select grid box. Once you select a grid box, you can see here, you see some box inside this protein which was not present before. Okay, also after selection of the grid box button, we see this box here and we see this smaller window here. This smaller window has two main things, the bottom part and the upper part. First of all, you need to select the bottom part. Okay, what this grid box means, you need to understand. It actually tells you where you want to dock your compound. For example, I want to dock my compound in this area. In other words, it actually asks you where is the active site of your protein. It actually asks you, tell me where exactly you want to dock your compound. In scientific term, this grid box area, we call it space search. So we are asking the programs to do a space search in this particular area. So how to select this box or how to fix this grid box? For example, my active site is this. Let's say this one. So the first thing is you need to bring the box down. So the first thing you need to adjust is the bottom part. This is X, this is Y, this is Z. Just like the coordinates x-axis, y-axis and z-axis. Okay, now if you put your mouse here and drag this way, you see it goes that way. Or if you see it goes here, you see it's moving. So let's say my docking area is this one. Okay, now here is, you see it's actually up and down. So let's say I'm selecting this area. Okay, and this one is the z-axis. So let's say this is my area, I have selected. Okay, now what these values means, it's actually the dimensions of this box. In other words, the size of this box. Okay, let's say you can see bigger, smaller. Let's say this is our box. I want to dock here. Now what exactly we need? Then what is the next step? Our grid box is selected, or we choose a grid box. Okay, the next thing is you need to type here snip if you are using Windows 10, otherwise use the screenshot button, open your snip tool and click the new. What you do, you can copy this or take a screenshot or use your mobile to take a picture. That's it. Why? I tell you now. Go to the same folder here and right click, new text document, and name it something just like I name CONF. That stand for configuration. So CONF, but that doesn't matter, you can name it anything. Okay, open it. Once you open it, you need to write some things. First you write center underscore X and then write the signs up equal. Now copy this and paste it 3 times. Okay, X, change this X to Y, change this X to Z. Now go down, write size underscore X, again the equal term sign, and once again copy this and paste it 2 more times. So Y and Z. A little earlier we made some picture, this one. Now the center value we need to write here. So what are the X center values? See here, that is minus 64.118, minus 64.118. What is the Y value? 26.642, 26.642. What is the Z value? Minus 30.603, minus 30.603. We will put all these 3 values, this is X, this is Y, this is Z, in the dimension or the sizes column here, 52, 50, 52, and you can close this, close it. 52, 50 and 52. Okay, save this that you do not waste it. Okay, come back here and delete this thing. Even you can delete the protein, doesn't matter, or you can hide it. Just click here, it will be hide. Okay, now we are going to select or prepare our ligand molecule quickly. The first step you need is to click here, input, open. Where is your ligand molecule? That is in the same directory, that is 123. Click here, all files that you can see, and click this ligand. You will have some option. Okay, doesn't matter. Now again click ligand, then torsion tree, and then choose torsion. Okay, you can see these names, or you may not see these names. That's okay. It means 3 rotatable bonds, done, among in the total 32. So click done. Let me do it again, that I choose torsions. Okay, 3. Okay, done. Now we want to save it. What the torsion means, if you are a basic or beginner, don't do it any experiments here, but for expert people, like in this ligand we have 32 bonds in total, 3 are rotatable, so if you are really an expert in in chemistry of the compound, and if you want some more bonds to movable or rotatable, and if that is allowed, you can do it, because it gives you an option. You can see make amide bond rotatable or not, etc, etc. So it will increase or decrease this number. Okay, now once you are done, then select the output, save as pdbqt. I will name it in this folder, I will name it, let's say L1. Let me write this way, L1.pdbqt. Save it. Okay, close this thing. Okay, why? Okay, so in our folder we have the CONF. We will open again. We will write here receptor equal, and what is the receptor name we prepared? P1.pdbqt, then ligand. What is the ligand name? L1.pdbqt. Give a space. Okay, one thing, you can also include exhaustiveness here. For example, you want more appropriate docking, so or in other words, if your compound has much more rotatable bonds. In my last video I have discussed in detail what is the importance of exhaustiveness. There we have used 8, but I suggested you to use 16. But let's say I'm not going to, but if you want to include it, you just write exhaustiveness here is equal to whatever the value is, but I'm not going to mention here. By default it is 8. Okay, save. Okay, the file is saved. Now our configuration file is ready. Vina is here, everything is closed. Now we are going for formal docking. You need to type here cmd, open. If you are not good in computer, then follow me. This cmd or command prompt, we call it command prompt. You can see here, this command prompt is basically here in the user ash. In my case, in your case it will be C user or some name here. So you need to bring it to the C. How you will bring back to the C? Just type cd dot enter. You see the ash has been removed. Do it again, cd dot enter. Now the program is on C. Now we need to bring the program to the folder where your files are. My files are here. How I will bring it here? Just click here. You will see this blue option, copy, and come back to the CMD and write cd, but this time do not write double dot, space and paste, Control V, enter. Now one final thing, you need to write dir. It will show you what files are present in this directory. It has CONF file, L1 pdbqt, ligand pdb, P1 pdbqt, protein. That's it. We know all, we have this. Now the second thing is we need to test our program. Just write Vina, enter. If you can see this kind of screen, it means that the Vina is working and it is asking for some proper command. So we will now write our proper command. So just write Vina space dash dash, or I would say double dash, write config. That means I'm providing you a configure file. So what is the name of your configure file? In my case, I name it conf. So you will write conf, that is text file, so txt. Now space, again we will write out. Out means our result file. So we will write the name of I will name it like, let's say, test underscore doc. Let's say I name test doc dot pdbqt. That's okay, I don't need the log file. So let's see how it goes. You can see the program is running. Warning, the search space volume is this. It means the space is very bigger, so that's okay. Program is working. When it reaches here, it will be 100%. Let's see. That's it. These are the energies, or these are the things. For it has generated 9 poses. These are the RMSD LB, RMSD UB, lower bound and upper bound, and this is the affinity of our molecule. Now I want, okay, if you, let's see to this folder, we have a result section generated. You can see here test docking with the name of test docking, and you can see here for every, it has 9 results as I showed you before, 9 poses. So for every pose you have energy. This is for model 1 minus 5.0, the LB RMSD or the UB RMSD. If you don't know, please read what is the upper bound and lower bound RMSD. This is for model 2. That's it. Okay, now let's say I want to make a PDB file. So you can use this one, and the same way you generated PDBQT, you can open this in any visualizer and convert it into the PDB file and make a PDB for yourself. So that's it. Let me open it, that whether how our docking looks like. Normally I use PyMol, so let's see. Okay, I will first open the PDB file which is present on desktop 123. Let's say I'm opening the protein file PDB. Now I open the test doc file. You can see here this is our compound, and if you see here it says 9. I already showed you it has generated 9 poses. So click this button. It's came here. That's because that box was very bigger. So that was just a demo stuffs. I wanted to tell you how to generate those things. Now, and exactly if you want to do this for your research, you should be very specific and very precise with your grid box. I would suggest, if you are taking 30 minutes for one dog, or let's say 1 hour for one dog, so in that 60 minutes you should spend 40 or 45 minutes with setting a grid box. because the main thing or the main success depends on the successful selection or the accurate selection of grade box. I hope you enjoy this video and you will learn something new from this video. Some of you have also requested about this video, so I'm happy I made it. And if you like this channel, if you want me to continue this work for you, please support me in the form of subscribers and share these information with your colleagues or with your students, or use it in your own research. I will be happy if you can take advantage of such kind of videos. Remember me, be happy, and goodbye.